Hello friends, now we will see one problem on gantry girder design. This is one university question for JNTU in the year April 2010. The details are given here. Design a gantry girder for an industrial building to carry an electric overhead traveling crane with the following data. Check the section for bending stresses. Crane capacity 200 kilonewton, weight of crane 100 kilonewton, wheelbase 3 meter, maximum hoop approach 1.2 meter, weight of crab 50 kilonewton, span of crane girder 15 meter, span of gantry girder is equal to 8 meter, weight of the rail is equal to 30 kilograms. Crane girder will be across the building. If you take one industrial shed, let us say here the width of the industrial shed is 15 meter. Then crane girder will be spanning along the width of the building. Crane girder will be spanning along the width of the building. Gantry girder will be spanning along the length of the building. Here, length of the building may be in the order of 60 meter or 100 meter. Spacing of the column is 8 meters. That is given as span of gantry girder. Span of the gantry girder is nothing but spacing of the columns. So gantry girder will be running along the length of the building. Length of the building can be 60 meter, 40 meter or 100 meter or anything. Width of the building is 15 meter. The crane girder will be run across the building. Crane girder will be spanning across the building. Here, this is the crane girder. The span is 15 meter. The load lifted is 200 kilonewton. That is given. And weight of the crab is 50 kilonewton. All these things have been explained in the design procedure, for which a separate video has been made. This 50 kilonewton is the weight of the crab. Crab will be moving in the bottom flange of the crane girder. So this 200 kilonewton is the weight of the load lifted, and this load is lifted by means of a crab which keeps moving through the bottom flange of the crane girder. Crane girder span is 15 meter. Width of the building is 15 meter. Crane girder span is equal to width of the building. Gantry girder will be spanning along the length of the building. Length of the building can be anything. It can be 60 meter or 100 meter, but spacing of the columns, that becomes the gantry girder span. Spacing of the columns is 8 meter, and that is being given as span of gantry girder 8 meters. Now this load lifted plus crab, that is 200 plus 50 kilonewton, can move closer to one column. There is a limitation. This distance cannot be 0. This distance is specified. This distance is given as 1.2 meter. It cannot move it cannot move beyond this. So place the load as close to the column as possible and calculate the value of RA. 250 load divided by span 15 meter into distance from another support. 1.2 meter is the distance from A. This distance is 15 minus 1.2. Load by span into distance from another support is equal to RA, 230 kilonewton. There are two wheels on the left hand side of the crane girder. There are two wheels on the right hand side of the crane girder. Therefore, this RA gets distributed through two wheels. 230 divided by 2 is equal to 115 kilonewton. This is the load transferred from the crane through the two wheels. Weight transferred through each wheel is 115 kilonewton. What about the crane girder weight? Crane girder weight is given as 100 kilonewton. This 100 kilonewton is distributed to the gantry girder through four wheels. Two wheels on left hand side, two wheels on right hand side. Therefore, weight of each load is 100 by 4 is equal to 25 kilonewton. That is the total wheel load. Total wheel load is 115 kilonewton plus 25 kilonewton. This is the wheel load due to load lifted plus scrap. This is the wheel load due to weight of crane girder. Total wheel load is 140 kilonewton. The spacing between the wheel load is given as 3 meter. Wheel base is equal to 3 meter. That means the distance between the two wheel loads is equal to 3 meter. Let it be denoted as A. Now we have to place the wheel load such that one of the wheel is at a distance of A by 4 from midspan of the gantry girder. A is the spacing between the wheel loads, that is 3 meter. A by 4 is equal to 3 by 4, 0.75 meter. One wheel load is placed at a distance of A by 4 from the midspan section. Total span of the gantry girder is 8 meter. Half of the span, 4 meter. Distance of the wheel load from midspan, 0.75. Therefore, this is 3.25 meter. And this wheel load is placed at a distance of 2.25 meter because 3 minus 0.75, 2.25. And this distance is 1.75. That is 4 minus 2.25. For this position, we have to calculate the reaction R1. 140 load divided by span 8 into distance from another support, that is 8 minus 3.25 is the distance from another support. This is the reaction of the one wheel load 140 kilonewton. What about the reaction due to the other wheel load? 140 load divided by span into distance from another support, that is 1.75. The total reaction R1 is equal to 113.8 kilonewton. Bending moment should be calculated under the load. Bending moment should be calculated under the load. Bending moment should be calculated under the load for getting the maximum bending moment. Mx1 113.8 into, that is R1, into the distance 3.25, that is 370 kilonewton meter. 113.8 into 3.25, 370 kilonewton meter. And there is an impact effect. The crane is electrically operated. Therefore, the impact effect is 25% more. Add 25%. This is the bending moment due to load lifted crab. And this is the bending moment due to impact effect. Add 25% more. 25% of 370. 370 into 0.25. 92.5 kilonewton meter. Then we are having the self weight of the gantry girder. Gantry girder is spanning between the columns. Spacing of the column is 8 meter. Span of the gantry girder is 8 meter. Take the self weight as 4 kilonewton per meter. Then bending moment due to self weight, WL square by 8, 32 kilonewton meter. Then we are having rails which are running on top of the gantry girder. It is 0.3 kilonewton per meter. 0.3 into L square by 8. That is equal to 2.4 kilonewton meter. Now, what is the total bending moment? We have to add Mx1, Mx2, Mx3, Mx4. Due to weight lifted and crab, it is this much. Due to impact effect, it is this much. Due to gantry girder self weight, it is this much. Due to weight of rails, it is this much. Add all of them. 370, 92.5, 32.4, it is 496.9 kilonewton meter. This is the vertical bending moment caused on the gantry girder. Now there is a surge load. Surge load is acting in the lateral direction. All these loads are acting in the vertical direction, whereas surge load is acting in the lateral direction. The magnitude of the surge load is 10% of the load lifted plus crab. Load lifted is 200 kilonewton. Crab load is 50 kilonewton. Total load is 250. 10% of that. And it is transferred on 2 gantry girders. Therefore, divide this by 2. And then that is, there are 2 wheels. We are calculating the wheel load. 10% of the load lifted plus scrap 250, 10% of that. There are two wheels, 1/2 is 12.5 kilonewton. This is the surge load. This is acting in the lateral direction. Now we have to calculate the bending moment due to surge load by proportion. When the wheel load is 140 kilonewton, the bending moment is 370 kilonewton meter. When the wheel load is 12.5 kilonewton, get it by proportion. 12.5 by 140 into 370 is 33 kilonewton meter. This is due to the lateral loads, which is due to the surge effect. And this lateral bending moment will be calculated by considering the ZYY of the section. Now we will choose an approximate section. Here the section chosen is one ISMB 600. Then we have a top flange plate 320 by 10 mm thick plate. Then we are having bottom flange plate 320 by 20. Then we are having one ISMC 400 placed horizontally. Why ISMC 400 is placed horizontally? Because we have to make the gantry girder rigid in the vertical direction also. ISMB 600 plus one flange plate 320 by 10 at top plus one flange plate at bottom 320 by 20 at bottom. All these things will make the gantry girder rigid in the vertical direction. Now we have to make the gantry girder rigid in the lateral direction also. For that purpose, we are placing one ISMC 400 in the horizontal direction. In addition to this, the gantry girder will always be laterally restrained by means of the bracing. Gantry girder will be running along the length of the building. This will be supported on the brackets from the column. Then adjacent to the gantry girder, there will be one tie beam. This tie beam will be supported on the column web. Tie beam and gantry girder both are parallel. Both are running along the length of the building. Tie beam is running along length of the building. Gantry girder is running along the length of the building. Both are running along the length of the building. Both are parallel. They are connected by means of a lateral bracing, by means of an angle. We should always provide the lateral restraint. In the case of beam supporting the floor, it is automatically restrained by means of the floor slab. In the case of beam supporting the bridge deck, it is automatically restrained by the bridge deck slab. And if there is no floor slab, there is no deck slab, we should provide a lateral restraint by means of a bracing. It is always possible to provide the lateral restraint. I-beam type is running parallel to the gantry girder. I-beam is connected to the web of the beam. This gantry girder is resting on a bracket which is connected to the flange of the column. Gantry girder is resting on a bracket which is connected to the flange of the column. Tie beam is supported on the web of the column. And ultimately, tie beam is also running along the length of the building. Gantry girder is also running along the length of the building. Both are parallel. It is easy to provide a lateral restraint by means of the bracing. There is no point in calculating the effect of lateral bending moment without any restraint. Saying that there is lateral buckling, there is torsional buckling, then having hundreds of equations. These equations for considering the effect of lateral buckling, torsional affecting, it is for the researchers. They want to get increment, they want to get PhD degree, and they will include it, they will push it into the code also. It is meaningless to consider the effect of torsional buckling, lateral buckling by using all those equations. We have to provide the lateral restraint. That is what is the job of an engineer. You have to provide the lateral restraint. You have to make it laterally rigid. Then full stress is allowed. It is always possible to provide the lateral restraint. and make the beam rigid in the lateral direction also. And the allowable stress is taken as the full value. There is no point in avoiding the lateral restraint and then calculating the effect of bending moment due to lateral bending, then torsional buckling, lateral buckling, this, that, and all. That is all idiotic approach. That is not for a practical engineer. The gantry girder is always provided with a lateral restraint. And for the section provided, the properties are available in the steel tables. ZXX is equal to this much. X mass is distance measured from the neutral axis up to the topmost point. It is in compression. Then bending stress due to vertical bending moment is equal to M by ZX. That is M by ZX is equal to 61.5 Newton per millimeter square. This is the sum of all the bending modes we have calculated. This is ZXX, M by ZXX. Then what about the bending moment due to lateral bending moment? M by IYY into X. Bending moment due to lateral bending is occurring in this point. IYY is given in the steel tables. X max is 200 mm. ISMC 400 is provided. If you measure the distance from the y-axis, the extreme point is located at a distance of 200, 400 by 2, 200 mm. X max, M by IYY into X max. This gives the stress due to lateral bending moment. The total stress can be obtained by adding these two values. The total stress, total bending stress is equal to stress due to vertical bending, stress due to lateral bending. That is coming to 61.5 plus 25.5, 87 Newton per millimeter square. What about the allowable stress? Allowable stress is equal to 0.66 times Fy. Fy is always 250 Newton per millimeter square. 250 into 0.66, 165 Newton per millimeter square. And actual stress, 87 Newton per millimeter square, is less than allowable stress, 165 Newton per millimeter square. Therefore, the section is safe. And this completes the gantry girder design. There is no question of calculating the effect of lateral buckling or torsional buckling. We have to take full value of the allowable stress because gantry girder is always restrained in the lateral direction by providing a bracing. These bracings will connect the gantry girder and the tie beam because tie beam and gantry girder both are running along the length of the building. Gantry girder is also spanning between the spacing of the columns. Tie beam is also spanning between the spacing of the columns. This completes the design of the gantry girder. Also, I am requesting you to visit my website https://rgnsite.wordpress.com. Here about 500 university questions and answers, detailed questions and answers, 500 university questions and answers on various structural engineering subjects, strength of materials, theory of structures, volume 1, volume 2, matrix methods of structure analysis, moment distribution method, slope deflection method, strain energy method, and then displacement method, force method. All the questions and answers are given in this wordpress.com. RCC design, steel design, also covered in this website. Download is free. Also visit my YouTube channel RGN class. If you plus YouTube, if you write press if you do the search engine in the YouTube, type RGN class. Some of my videos will come along with other videos which are relevant. Choose one of my video. There will be one icon or you press the top, then you will have totally my videos only. So my name of my YouTube channel is RGN class. Use this in the search engine. Once you type RGN class, you will get some of my videos along with other irrelevant videos. Choose one of my video. There, my icon or will be there. You press that icon or then you will have only my videos appearing in the list. That videos will cover the subjects of structural analysis and design. This question is also included in the wordpress.com. Please visit my site rgnsite.wordpress.com. Thank you all.